Hello and welcome to the session. Databases LO2. Be able to design a relational database based on user specifications. Imagine a world where data is organized perfectly to meet user needs. This video explores the journey of designing a relational database from user specifications. Discover how to translate user requirements into a structured database design. Designing a database begins with understanding user needs. Identify what data needs storage and how it will be used. Determine who will access the data and what outputs are required. Clarity in these specifications is crucial. Poorly defined requirements lead to inadequate database design. The design process involves identifying entities like customers or products. Define attributes for each entity, including data types. Assign primary keys to uniquely identify records. Create relationships between entities using foreign keys. Apply normalization to remove redundancy and improve data integrity. In the relational model, data is split into separate tables. Explicit relationships replace duplicated information. This approach ensures a reliable, maintainable, and scalable database. It aligns technical structure with real-world business processes. Accurate and consistent data is the result. Identifying user requirements is foundational for effective database design. Understand what data users need and how they will use it. This process is not initially technical. It starts with understanding the application context and user activities. User requirements guide the scope of the database. Entity relationship diagrams visually represent user requirements. Entities represent real-world objects like student or course. Attributes describe data for each entity, such as student ID or name. Relationships show connections between entities, like enrollment on a course. Cardinality defines the nature of these relationships. Diagramming tools like Lucidchart are used to create ERDs. They provide standard symbols and clear layouts. Entities, attributes, and relationships are visually organized. This process supports collaboration and ensures accuracy. ERDs can be easily updated if user needs change. Accurate ERD creation ensures the database is fit for purpose. It prevents overcomplicated designs and reduces future rework. The final database aligns with real user needs. This step is crucial in preventing assumptions. Clear ERDs validate requirements before the database is built. Consider a student course management system. User requirements include storing student details and course information. Students can enroll on multiple courses. The system must prevent duplicate enrollments. Entities identified include student, course, and enrollment. Each entity includes attributes that reflect user data needs. Student entity has attributes like student ID and email. Course entity includes course ID and course name. Enrollment entity has enrollment ID and enrollment date. Primary keys uniquely identify each record. One student can have many enrollments. One course can have many enrollments. Each enrollment links one student to one course. This results in a one-to-many relationship. The many-to-many relationship is resolved through the enrollment entity. In a diagramming tool, ERD is shown using rectangles for entities. Ovals or listed fields represent attributes. Lines with crow's feet indicate cardinality. PK and FK labels show key relationships. This visual representation aids in understanding and validation. The ERD meets original user requirements by storing all required data. It supports multiple course enrollments per student. Relationships are enforced through foreign keys. The structure is clear and can be implemented as a relational database. This alignment with user expectations ensures effectiveness. Normalization organizes data in a database to reduce duplication. It involves breaking large tables into smaller, well-structured ones. Clear relationships are defined between them. The main purpose is to store each piece of data once. This ensures data integrity and ease of maintenance. First, normal form eliminates repeating groups and ensures atomic values. Second normal form removes partial dependency in composite keys. Third normal form removes transitive dependency. Most databases aim for third normal form. It balances structure and performance effectively. Consider an unnormalized table storing student enrollment data. This structure creates redundancy with repeated tutor and course names. After normalization, student data is in a student table. Course data is in a course table. Enrollments are stored separately, ensuring clear purpose and relationships. Normalization reduces data redundancy and protects data integrity. It ensures changes are made in one place, reducing anomalies. From a maintenance perspective, normalized databases are easier to update. They support clearer design and more reliable querying. Normalization is essential for scalable database systems. To implement a database from an ERD, convert entities into tables. Attributes become columns with appropriate data types. Primary keys are set as primary key constraints. Relationships use foreign key constraints. Many-to-many relationships require a junction table like enrollment. Create tables for students, courses, and enrollments. Students and courses are stored in separate tables. Enrollments link students to courses using foreign keys. Unit constraint prevents duplicate enrollments. On-delete cascade maintains integrity when removing related records. Load test data into the database to evaluate the schema. Check that tables exist and match ERD entities. Ensure primary keys uniquely identify records. Foreign keys must enforce relationships correctly. Test queries should produce correct results and join related data. In conclusion, the ability to design a relational database based on user specifications is essential for creating effective and efficient data solutions. This involves analyzing user requirements, identifying entities and relationships, and applying normalization principles to ensure data integrity and minimize redundancy. A well-designed relational database supports accurate data storage, efficient querying, and reliable system performance. Being able to design databases according to user needs ensures that information systems are both functional and scalable. Thank you for watching this video. If you have any questions, please feel free to contact us via email or WhatsApp at 07484361688.